Okay, so today chemistry. Under chemistry today, we'll start looking at atoms, molecules, and compounds. Okay. Now, before we go any further, before we look at all these, we're supposed to understand what an atom is. So, an atom is a smallest particle. Is the smallest particle of an element that takes part in a chemical reaction. Or we can say an atom, it is the smallest particle that has got chemical properties. In short, other books you find it like that. So now, before we go any further, an atom, in short, an atom has three subatomic particles. Or an atom consists of three subatomic particles, and the three subatomic particles of any atom is one is what we call protons. Okay, protons are positively charged. Okay, while the other one is the electrons. Okay, electrons are negatively what? Charged. And then there is also the last one called what? Neutrons. Neutrons, these ones have got no charge. They are neutral. Something which is a neutron comes from something which is neutral, meaning that they have got no charge at all. So when you come to look at the structure of an atom, meaning that we're going to have some energy levels there, we're going to have that one there, and we can also have another one. This is what you call the nucleus. The nucleus of an atom consists of protons and neutrons. The nucleus of any atom consists of protons and neutrons. So here there are protons and there are neutrons. Then around it is surrounded by what? Electrons. All these are electrons that move in what we call energy what? Shells. These are energy levels in short. So these are electrons. And then these are electronic shells. So which means this is how an atom or the structure of atoms are. Then apart from that, we're supposed also to look at apart from that structure of an atom, we're also supposed to look at now into details of this. So the mass, this one I've got the smallest mass, and then these ones have got at least a bigger mass than this one. Then the charge for this one is the -1, and then the charge for this one is the +1, and then these have got no charge at all. So in short, atoms are electrically neutral. These are neutral. Atoms are electrically neutral. What does it mean? It means when something is neutral, meaning that it is not losing or gaining. Meaning that all atoms are electrically neutral, meaning that if they are neutral, that means they have got equal number of protons and also electrons. Why? Because they are neutral. When something is neutral, like I said, when that atom is neutral, it is neither losing or gaining any electrons. And then we come to what we call nuclear notation, but I'll explain more on this part here, you understand more. Then we come to what we call nuclide notation. Okay, let's talk about how these are denoted, how atoms, elements are denoted. So meaning that we can have A here, we can have X here, we have A, Z. The number on top is called the nucleon. nucleon number. The other term that we use nucleon number, we use the mass number. What is this nucleon number? It is the total number of protons. It is the total number of protons and the neutrons. It is the total number of protons and neutrons in an atom. Then the X here represents the what? The symbol. And then the Z here represents the proton. The other name for proton is what? Atomic number. Then we can find the neutrons there. How do you find the neutrons? You find the neutrons by saying neutrons is equal to A minus Z, like that. So an example that I can give is maybe, for example, you have got sodium Na, you have got 23, you have got 11 here. So the symbol, this is sodium. This is the symbol for sodium. So this represents the symbol. So you can say A, our nucleon number is 23. Our Z, which is the proton number, is what? 11. How do you find the neutrons? So the neutrons you subtract, which is A minus Z, which is 23 minus 11. So the number of neutrons is what? 12 there, like that. So this is what we have under that nuclide notation there. And then apart from that, we can continue now to look at the electronic configuration. So to say, I can talk about the electronic configuration there. Okay, so this is the nuclide notation there, but I can continue to look at that. So sometimes you can have other elements that will be taught, maybe to find maybe the number of protons, the nucleon number, and the number of neutrons there. So that is what we get there. And then, as we said, that all atoms are electrically neutral, mean that they've got equal number of protons and equal number of what? Electrons and also protons there. So, like I said, since we have got sodium there, which is 23 and 11, if we say how many electrons does this sodium have, it has got how many electrons? 11. How many protons does it have? 11, because they're electrically what? Neutral, mean that they've got equal. So where we're going, you'll be able to understand more on that part there. So now when it comes to electronic configuration now, which is the electronic configuration. Okay, when you're looking at the electronic configuration there, we're just talking about, this is just the distribution of electrons in the shells. Okay, so the first shell has got 2 electrons, the second one has got 8, the other one 8, and then just like that. So for example, let's talk about sodium. If I say sodium, there is 23 and 11. The electronic configuration, we use the electrons. How many electrons do you have in this sodium? We've got 11. When I distribute this 11, I'm going to have the first shell contains 2, the second shell is 8, then the last one is what? The remainder, which is 2,8,1. If I was to draw that, I'm going to draw shell number 1, shell number 2, and the third shell there. So I've got 2 there, 1, 2, and then we've got 8, 1, 2, 2, 2, and 2 there, which is 8, and then 1 there. So this is what we call a sodium there. And then apart from that, maybe you can have maybe calcium, which is Ca. Calcium is 40, and this is 20 down there. So the electrons there, they are 20. So when you write the electronic configuration, it's 2, 8, 2,8, which is 10, another 8, and then 2 there. So again, when you're going to have how many shells? 4 shells there. You're going to have 4 shells. If you want, you can even use dots. We can use 2, which is 1, 2, 3, 4, 5, 6, 7, 8. Again, 1, 2, 3, 4, 5, 6, 7, 8. Again, you're going to have 1, 2. This is about calcium. That is calcium that you have there. So this is about electronic configuration, and this shows when we go any further on the periodic table, we find that the number of shells represents the period. So number, the shells, in short, the shells represents the what? The period in which an element is on the periodic table, and then the last shell, or the last shell, or the outermost shell, or the electron, the number at the last one, the last shell number represents the group. It represents the group in which an element is on the periodic table. If you can just check, if you go there on the periodic table, can you check what sodium is? Sodium is in group what? 1. Sodium is in group 1 and period 3. You can count the way the periodic table is. The period, in short, period on the periodic table is what? Horizontally. Starting from hydrogen, then the groups now, the groups are what? Vertical. In the vertical, you find that it is just the first one there. Then this, it is 1, 2, 3. Even here, this one is in group what? 2. Calcium is in group 2, and then it is in period what? 4. That is how you identify what is the period and also the group of that element. I think that is just the introduction to atomic chemistry there, or about atoms there. So for any questions, please forward them, and then I'll proceed to look at another lesson under those ones. Thank you so much.